So yeah, I mean, I think, so right now, the first meeting, we kind of just like got people's perspectives on profiling in general. The second meeting, we started to talk more about like, what is the goal of a new format? Like what things should it accomplish? And then this third meeting, we're gonna kind of talk about the one that's coming up next Thursday. We're gonna talk about, okay, so like, you know, we're kind of like drilling down further and further. So then it's like, now, like, what are examples of, you know, current profiles and where they lack, and potential candidates for what the new spec will be, you know, moving forward. And that's kind of the part where we'll present this.
Okay, so maybe one thing we could do is like Anton would present.
He already did it twice. I feel bad.
Well,
you mind doing it one more?
No problem at all. I would maybe suggest starting from reviewing pprof format, because for us,
yes,
it's a starting point actually. So,
yeah, I think that would be.
Let's get started.
Yeah, do you have like the images for both? Because I also think the images are just like way nicer to look at.
Okay.
They're in that document.
For pprof, we can find it here. I will switch between the original protocol specification in the picture. By the way, guys, are you familiar with the protocol buffers? Yeah, if you have any questions, interrupt me anytime, you know. So first of all, pprof history is quite interesting because the format is pretty old, and initially it was using Google for C++ and C programs. And therefore, it kind of inherited some properties that I'd say, well, more or less specific to native applications. For example, that addresses things, mapping between the library addresses and symbols and so on and so forth. This all came from its, I'd say, past. But yeah, nevertheless, then pprof started, basically Go team started using pprof internally and made it the official standard for Go profiling. The same, by the way, for Node. V8 agent also supports pprof format natively. A binary representation of pprof described here in protocol buffers. Let's maybe outline key characteristics of the format. It can be represented, well, let's maybe go through the members. Our root level structure is profile, which is understood. Then let's skip this field for now. Then a profile contains multiple samples, an array of samples, basically. And every such a sample includes an array of locations or pointers to locations, an array of values, and an array of labels. In turn, every label can be represented as a kind of another structure that points to strings or contains numbers. This is very weird thing, and we don't use it. We only rely on string values. So yeah, let's keep it for now. And as you can see, it's and I want to emphasize that every sample represents a particular stack with some values captured during profiling session. And imagine that if we have many samples, and we, for example, tag every span with the profile ID label, that means that in most cases, most of samples will hold kind of completely identical set of location IDs because they point to the same code path in the program, right? For example, somewhere in the request handler. And the same for labels. Most of them will be same, apart from maybe span ID or profile ID label. And this all makes it very inefficient to kind of encode these samples and process. So yeah, let's go ahead. Every location in this array points to a member in this field, locations, so, another array again. Meanwhile, every such location points to one or more functions. Allocation typically points to more than one function in case if they were inlined. And every function can be described as, with its name, with its location. What else I should?
Wait, where is the pointer to the function? You say location is mapped to multiple functions, and I don't see function field.
Yeah, it's here. It's indirect. Location refers to ally, and function ID then refers to another. It's a bit, complicated, but not that much. Also, not this one, this one. Some things in the specification are completely irrelevant to our use case. They are used in pprof tool which has nothing to do with the continuous profiling. Another very weird thing is that a profile can contain, let's say, samples of various types. For example, in Go, heap profile contains 4 types of profiles: allocated objects, allocated space, in-use objects, in-use space. And we distinguish between them. Let me show you. We distinguish the profile type based on the, how should I put it? On this thing, sample type. This is an array that basically specifies a unit for sample value of specific type. And every value in this array, in the array of sample values, has a corresponding value type in the sample type array, which is very confusing. For example, first element in this array will be for in-use object, second for in-use space, and so on. And same here, first value will represent like in-use space, second value in-use objects, and so on and so forth. It's not really, it doesn't really work well because various sample types or profile types not necessarily contain same samples, and not in the most cases this array is kind of half empty, for at least for Go heap. By empty I mean it just contains 0 values. Yeah, either way, do you follow so far? Everything is clear?
Yep.
Okay, cool. So and now I'd like to take a look into the OpenTelemetry specifications briefly. The very concept of OpenTelemetry standards is that they have some resource, for example, metrics, and then they describe scopes. They treat these, I'd say, signals as something that's bound to a particular scope. For example, by scope, we can take a request. So we will have metrics for a particular request, and it's kind of can be named scope. In our case, in profiling world, we typically use we typically name it like execution scope, and basically these things are the same. The problem is that in pprof format, it's hard to describe multiple execution scopes or just scopes within a single document, within a single profile. Why? Because the only way you can do this is by using label sets with unique combination of values. It's really inconvenient. It's implicit. It's hard to process, and it's inefficient in terms of space requirements and memory allocations during decoding and encoding, by the way. So I came up with a couple of ideas how we can solve some of the problems. The general structure of this draft is, similar to the existing OpenTelemetry specifications. So I won't focus on these things like resource, schema URL, instrumentation scope. As you can see, it's these fields were just inherited from OpenTelemetry standard. Let's take a look at the profile scope profiles type. It contains multiple profiles. Meanwhile, it also contains the data that's shared among profiles. For example, stack traces, locations, function names, string table. This data is used within every particular profile. We can say that a profile references some things from the scope profiles message. And yeah, first of all, first improvement is the replacement of this array of location IDs, basically a stack. And typically, actually, this array is quite big. I mean, in Java, I guess it can be like hundreds of locations because of very deep stacks. In Go, they have a limit on CPU stacks, like 64 and 32 for memory, but nevertheless, these arrays are pretty big. Instead, and yeah,
sorry, can you re-explain that? So you're saying that this sample array,
yeah, this array in the sample message can be pretty big depending on the depth of the sample, of the captured sample.
How many stacks there is, yeah.
So that's like how many
frames? How many frames, yeah, in the stack. And typically, the array length is, I'd say, greater than 16 or even 32. And yeah, and in most cases, if we describe many execution scopes within one profile, these arrays are going to be equal. I mean, literally, they will point to the same stack. For example, yeah, HTTP request handler or some function call within your span.
Basically, you're saying like if you have some tag that's like user ID 123 and it's the same like handler in the controller, the stack trace is going to look the same, but it's going to have different labels, and so we're going to have a bunch of kind of like repeated data.
Yeah. And the same for labels, the same, she doesn't return values. But for this array, it's very important to, reduce the data duplication. Therefore, instead of including this array into every sample, we pre-calculate them in advance. We introduced a new thing, stack trace, and then we can kind of refer to it from profile. We have an array of stack trace IDs, and every element in this array points to a particular stack trace. So instead of a, I'd say, multidimensional array, instead of matrix, we have just a one-dimensional, a single dimension array, which is, yeah, way more efficient approach. And the same, we store values for corresponding stack traces in another array next to the first one, next to the stack trace IDs array. From the processing perspective, it's for us, it's, you know, it's very good thing because we don't need to allocate a bunch of tiny objects and can handle a lot of profiles without any, you know, memory pressure or garbage collection pressure. Yeah, just a side note. And yeah, as you can see, now our profile contains multiple profiles, and every such profile has an explicit name, explicit unit, explicit time range, and yeah, this thing was borrowed from matrix definition. You know, basically our profile types can be of various kinds. Sometimes some of profiles are just, you know, like counters in Prometheus. Others, like gauges, we call it cumulative profiles. It's interesting that OpenTelemetry guys have a similar concept. Yeah, they have delta profiles. For example, a CPU profile. We start profiling session, for example, for 10 minutes. We capture a profile for this, I'm sorry, 10 seconds. For this 10 seconds. And every value in this profile represents a delta comparing to the previous profile. Or cumulative. Cumulative values never decrease. They only grow and kind of accumulate the, for example, allocations or allocated objects. Aggregation temporality.
Mm-hmm. Oh, is that what you were explaining just now?
Yeah, no worries. Actually, yeah, the problem we have right now in the current pprof implementation is that some of profile types, for example, in use space and in use objects, are of cumulative type. Their values never decrease, they only grow with time, over time. And we need to kind of calculate a diff with the previous profile every time a new profile emerges. And for example, CPU profiles are a bit different because they are present at delta. I mean, the values contain delta compared to the previous profile. For example, you captured a profile, and the next one, how should I put it? The next one can be interpreted independently. It doesn't require you to compare it or do anything with the previous profile. Meanwhile, cumulative profiles require you to calculate the difference with the previous profile to get the actual value. It's
Yeah,
well,
that makes sense.
It sounds a bit confusing.
No, I think that makes sense.
And the problem is that there is no way to figure out the, I'd say, sample type kind in the current pprof, because it doesn't have such information. Therefore, we have to maintain a configuration on our side. And we know that, for example, in use objects and in use space profile types are of cumulative kind, of cumulative type, and we should handle them in a, special way. And this is really inconvenient. Instead, it's better to explicitly specify this aggregation temporality thing for every profile on the producer side. It's just, I should say that this thing is optional because it's going to work even without it. But with this thing, it's a bit more convenient. Okay. Next thing, sample size. Sometimes our values in a profile specify not the absolute values, but the number of samples captured. Basically, the number of times a particular stack was thin during the execution. For example, in Go, CPU profile, then Ruby spy, PySpy, PHP spy. If I'm mistaken, all they specify number of samples captured instead of the actual CPU time. And therefore, we have to normalize all the values. Because, for example, imagine that one host you use sample rate 15, and another host is configured with the sample rate 100. Apparently, you won't be able to compare the values of these profiles without extra processing. And you have to know the actual sample rate. And instead, you can specify a size of every sample so that this value will represent not an absolute value, but the number of samples. And then the absolute value can be calculated by multiplying it by sample size. There's another use case not considered in this document, but I left a comment about it. It's when our collection is sampled. For example, we run our profiling session for 10 seconds during a minute. And that's how, for example, profiling works in Google Cloud. What's next?
I want to also clarify, like some customers asked us about it because they're familiar with that, and like for various reasons they might only want to like either profile like only like 2% of their whole fleet, or they want to profile every like 10 seconds out of a minute, out of 10 minutes. Like everyone has like slightly different opinions on how to do that. So like we might introduce support for that in the future.
Yeah, maybe something like sample base, or I don't know.
Yeah, like
we should perhaps discuss this separately. Okay, the next field is a set of attributes, arbitrary key value pairs, and also this approach was kind of inherited from the original OpenTelemetry specifications. Another thing is very interesting. As I mentioned in the very beginning, that OpenTelemetry scopes very similar to the execution scopes in profiling world. And to be precise, actually, we can establish one-to-one mapping between the execution scope or unit of work or whatever we call it, with a span, in terms of OpenTelemetry. And this field allows you to link a particular profile to a span, actually to multiple spans. It can give us a very simple way to integrate tracing and profiling, both for tracing platforms and for profiling platforms. And yeah, a log think is the most interesting one. We already discussed it, but yeah, we represent a profile with two arrays. One array contains stack trace IDs, and the second array contains corresponding values. Every stack trace ID in this array points to an element in stack traces array in the ScopeProfiles member. Meanwhile, every stack trace points to an array of locations, basically stack frames. And I'm not 100% sure that this representation is, robust enough, because in continuous profiling, people may think that a profile should describe, I'd say continuous profile.
Like you
but it
mean
doesn't
like
make any
a
sense.
sample and timestamp kind of thing, right? Like, because right now it's all
Yeah.
aggregated, and you're saying like people might expect it to have kind of like
Yeah.
timing information for samples, right?
Exactly. Some people picture a continuous profile as I'd say set of time series, where every time series is characterized or identified by its stack trace ID. And perhaps their approach is more appropriate, but I'm not sure. Therefore, I decided to keep it simple.
I think, well, I have two thoughts on that. One, yeah, I don't think we're gonna go into like having timestamps in these profiles anytime soon. This will probably come up in some of these meetings, and I wonder what others think, but I don't think there's like, that much kind of demand for that. The other thing else,
Why not?
because it's like no one does it like that, and it's
yeah, actually I can
like
express
this extra kind of stuff to store.
Yeah, I have some thoughts on this.
Mm-hmm.
First of all, typically, well, yeah, actually, there's one big assumption that I didn't voice in the very beginning, but this profile describes a sampled profile, right? Because, for example, in .NET and perhaps in GFR, they describe events, right? And then, I mean, like, event like particular call has happened or started or ended and whatever. In our case, we already have sampled values, sampled over time. And
like
typically,
in Go, we can't even get to that information, right? Is that kind of what you're saying, or something else?
Yeah. And the same for Ruby Spy, PySpy, PHP Spy, and many others.
That's not entirely true, actually. For PySpy and Ruby Spy, we potentially could get timestamp information, I think.
Yeah, but you sure? I mean, is it public interface or it's internal?
It's going to be private. Yeah. So it's going to be tricky. Like you can't just get it.
Of course. Yeah, of course. Yeah, if you have access to their own time or maybe can communicate to it, it's possible. But we have what we have.
Yeah. But anyway, the other thing,
and typically profiles like this are captured over pretty, long period, like 10 seconds. It's infinity in terms of an application or a request. And therefore, it simply, doesn't make any sense to represent a profile as a in a time series fashion, to my mind.
I mean, yes, like people definitely asked for like something like that before.
I'd say that this idea may be valid for data at rest formats, but for data in transit, I mean, data
but even
at rest,
from like
I mean, how
high
to
level,
store
from
this.
like user perspective, some users want to be able to like not just look at like 10-second resolution, but they want to go deeper. They want to be like, oh, but like which specific, 100 milliseconds did this kind of happen in, right? Like some people definitely ask for this kind of stuff. And if we included timestamps here, like that would kind of answer their questions.
Yeah, I was considering this option. Let me maybe.
And like the other thing I was going to say is like it kind of seems like from this way you're architecting it, it would be relatively easy to add that. Don't you just add another like repeated, timestamps kind of thing?
No, you don't need it. Instead, you should put something like this and build, I'd say, an array of, I don't know, gauges or whatever you need. I'd say a number data point should work for us.
Okay. Anyway, yeah, I don't think we should like kind of focus on this too much because I don't think that's gonna like. It doesn't seem like anyone is gonna actually like want to do it anytime soon. But Ryan, what do you think?
To me, it seems reasonable to have a timestamp of like
each sample.
Of like if you're sending a profile from the client to somewhere, it seems like it would be nice to know like what data is encapsulated in that profile. So like when it's
have it.
Okay, so are you talking about something different than this?
Yeah. It's about, for example, imagine that you want to represent the minute of time. And how you should do this?
Wouldn't that be represented there with start time and end time?
Yeah, for example, typically profiles are captured every, for example, 10 seconds. So you potentially could include just 6 profiles for every 10 seconds, right? And then you can kind of specify stack traces and values in each of them, right? Alternatively, you could build it in a different way. Imagine that every stack trace ID would have its own time series, like a metric for every stack trace ID. And then you could kind of encode everything, I mean, data for this time range, like a minute or 10 minutes or an hour, doesn't really matter, within a single profile. And in this particular use case, it does make sense to use time series data because you wouldn't need to specify stack trace ID every time for every profile.
So you're saying basically like on line 126, like add like repeated data point or whatever they call it, like gauge or something. And that would, so instead of like, right now there's just one value with number.
Yeah.
In this kind of like different iteration, it would be like a series of like timestamp value, timestamp value, timestamp value.
Yeah, the problem is that protocol buffers encoding isn't very inefficient for this implementation. We could implement something like Gorilla or Zigzag encoding.
Like the stuff where you like do like one minus the other and basically store like
delta. Yes, something like delta encoding, stuff like this. Either way, instead of an absolute scalar value, we could put either a vector here or time series.
So yeah, so Ryan, like, I feel like we have like multiple kind of options for this. We could like, I mean, like we could at least bring it up kind of like with the
Yeah,
OTel.
I think it'd be a good question to ask.
Yeah. And also like maybe we add support for it in the format, but like don't actually use it.
Yeah,
know?
that was my idea. I left a comment, but didn't solve it yet.
Because like I could see eventually in the future, like us or others kind of taking advantage of this.
Yeah.